Stars are whispering tales of old, planets spinning, stories bold. Life is dancing through the night, countless worlds in the starlight. Galaxies full of mystery, infinite in their history. Beyond our dreams and our sights, life blooms in the cosmic lights, dancing on the edge of space. Take me away, feeling the universal grace. In the dark our hearts ignite, life across the endless night. Nebulas with colors bright, birth new wonders in the light. Comets trail their sparkling tears, life endures through the years. In the silence of the void, every heartbeat is enjoyed. From the depths and to the heights, life expands through cosmic night. Dancing on the edge of space, and off we go, feeling the universal grace. In the dark our hearts ignite, life across the endless night. Dancing on the edge of space, and off we go, feeling the universal grace. In the dark our hearts ignite, life across the endless night.
Mark, I'm okay. Can you hear me? Oh, okay. I lost the mic again for a minute there. Hello, everybody.
Okay, all you heard was Daryl there for a minute because my microphone went muted again, my mistake. So I'll start over. Hello everybody, welcome to Skyther Livestream tonight. It is I, Mark D'Antonio, and as before, I mentioned, and you didn't hear me say it, but Daryl Mason is joining us tonight, and I said hello, and then he just said hi. So there we go. Well, I'm glad you were able to join us again, Daryl. Everybody missed you, and it's nice to have you with us again.
Mark, I've got the feedback going on again.
Okay, I don't know why, but okay, let's try this. How about this? Is that better? Yeah. Yeah, hold on. How about now? You still have feedback, Daryl?
No.
Okay. All right, we're good.
God, I hope so.
Yeah, we're good. We're good. We're good. Anyway,
Okay.
welcome, guys. Welcome, welcome, welcome. And tonight we have a special treat because this is the Benson telescope right here, and this is the Sonoran telescope. We have both telescopes open tonight. Benson may go down early because of impending weather coming our way, but it's been a reliable observatory, so we don't have any, I say necessarily, necessary stopping points, right? So I will just do our beginning stuff here that we do. I'm gonna start it up. I'm gonna move it to its what we call a home position. Okay, we have two cameras in there now. As you can see, we have one tracking camera. I have tracking off, otherwise it'd be following it around wherever it went. And then we have the second camera, which is in the fixed position, or by what we call the mouse hole. All right. And so that's our home position. So now you're being treated to a little bit of our startup process. So I'm just gonna take this guy and move these down. This is our control cluster telescope right here. All right, and this is our rendering of the telescope position right here that you can see. And I'll make that a little bit smaller because we don't need it to be in the way. That'll do. All right. So that said, I'm really happy to say hi to everybody. Welcome to the show tonight, and we're going to be looking at some really cool things tonight. We've got a whole bunch of objects to look at. You kind of saw a hint over with the Sonoran telescope here in the west. This is in constellation of Leo Minor, and Daryl brought this galaxy up tonight. As a matter of fact, this one to look at. It's small in this telescope because in this particular telescope, remember we have a 1.5 by 1 degree field. All right, and in that 1.5 by 1 degree field, well, unfortunately, the galaxy is pretty small in there. In the Benson telescope, it's going to be a lot bigger. But what I'll do is, while we're here waiting, I will actually start an exposure. I want to just check our focus. It looks like we have to do a little bit of a focus run here. So I'll start that. And after I get that underway, I'll come over to the other telescope. And that's, the Benson telescope. Actually, that looks pretty good right there. Oh, I'm happy with that. That looks pretty good. Okay, so what we're going to do now is we're going to do a 25-second photo here. Again, we're at f1.8, which is a very, very fast photographic speed. All right, so we're going to start that. And this is our low light mode. All right, and we're going to go into our deep sky mode here and come out of this momentarily, and we'll get back to that in just a minute. So Daryl, what's been going on since we last talked, the last time you were here?
Oh golly, I don't know where to start. I was sick for months.
Yeah.
You knew that. I suspect it was long COVID. It hit me in December,
Oh, wow.
and it kept coming back on me like once or twice a month. I had it really bad in late May.
Oh.
And I finally feel halfway normal, and I'm really rusty. I can see here now, so I hope you all will bear with me.
It's okay. Trust me. Your presence was missed, and there wasn't a stream that went by when people said, "Hey, where the heck's Daryl? We don't want to hear you anymore, Mark." And that was that.
Well, I always said you'll miss me when I'm gone. But I'm
Okay.
back for now, at
Excellent.
least.
Excellent. Okay.
We'll see.
Just
What
on
else
there,
has been going on?
so everybody knows, we're actually taking exposure of a faint galaxy over in the Sonoran telescope. We'll come back to that shortly. All right. And over here in the Benson telescope, we are currently not looking at anything in particular right now. We're in our home position. But there. So that's it. Go ahead, Daryl.
Well, I forget what I was saying now.
You're telling us what's been happening since we last talked.
Oh, what else has been happening? I had my annual physical recently, and all this came up, and the doctor is kind of non-committal. And the one thing she said, and I already knew, is, well, it's viral in nature, so pretty much all you can do is write it out, you know. And God, I've been writing it out since December.
Yeah, it's like you're okay now.
I'm okay for now, at least. I don't know. Hopefully it doesn't come back again. What else has been going on? Oh, gosh, I don't know. I've been sort of vegetating and trying to keep a low profile and trying to get better. And hopefully, here I am.
Yeah, well, I hope you do.
Yeah, there's been other things going on, and I don't know. I don't want to bore you with it. I frankly can't remember at the moment anyway.
But then you can't bore us with it.
Right.
You can't bore us with it if you don't remember it, you know?
Well,
So.
I'm old.
Nah. Okay, so let me just do one last little bit of house cleaning here. I need to come back to the video here, and I need to get the chat, so I'm gonna do that. Okay, this should be it. Here we go. And here's my chat. Wow, have a lot of people here already. Thanks, guys. Good to see you. I'll say hi to you in just a moment. Alright. I popped it out, and now the chat is available to me. I mean, it was before, but now I can see everybody who's here at the same time. That's good. Wow, I did mention it to a lot of folks. I want to say hi to Tiffany Echo, who was first. We have Carl Becker. Hi, Carl. Toner. I see you. Richard Spencer. Good to see you as well from Ontario. Nice to hear from you. Daisy and Zoe are with us. The Goblin's with us. And we have Sam S. Good to see Sam, as always. And Kevin O'Neill's with us. Nice to see you. Yeah, and of course Ronald is with us. Ronald, okay, this telescope right here that we have is courtesy of Ronald. Actually, he donated this telescope to us. Actually, he gave us the ability to get it. And
what a guy.
I know. One of these days, you know what, Ronald, when we put the plaque in there, should I get a security cam in here that looks just at your plaque? Or this pan tilt will actually allow us to get to it. So depending on where we put it, I might be able to say, here, let me show you his plaque, and just like go over to one side and show it to you. That might be cool too, because no one else has a dynamic plaque.
Ronald will always be Yosemite Sam to me. Don't ask me why, because I know he doesn't look anything like him, but
he looks more like Robin Williams.
Somehow he's always been Yosemite Sam in my mind's eye.
That's funny. Oh man. Hey Stuffy. Nice to see you. And Donald Kunzer, how you doing? Good to see you guys. Sarge is with us. Oh yeah, okay. So, that all said, what I'm going to do now is, now we still have some sunset light, which is making the imagery just a little bit red, okay, and here is in the Sonoran telescope. I'm I'm taking an image of that. Let me just pop over to that quickly to show you what that looks like. Okay, this is, right now this is NGC 3344, Galaxy magnitude 3.98. We'll save this with annotations while we're here. Oops, that was a mistake. I should have actually set the target first. Now it's going to complain, and that's fine. I'll just save it again. Okay, I make that mistake sometimes.
Magnitude 9.98.
Yeah, 9.98, sorry. I think I misspoke, huh? I thought I said 9 something, but maybe I didn't.
You said 3 something.
I did? Oh, wow.
I thought you did.
Okay. Well, that's a, if I did, it's a brain blip. Okay. Yeah, so we'll zoom in just a little bit with this camera so we can see a little of the spiral structure there. Let me add a bit of a unsharp mask. Let's try and get that to show us a little more detail in there. And it kind of does. Let's get rid of some of the other noise. Watch it go away instantly. Boom. That's nice. Okay, so we'll let that develop for a while. We've got 16 images taken. And over in the other telescope, in the Benson telescope, we're going to go with the same thing. So let's go and look for NGC 3344. I don't think it'll do it just by looking at this, right? Yeah, no. Let's just have to. You have to prefix it. NGC 3344. Whoops. All right, that will do it. Now we'll get it. All right, so we want this, and it's over there. It's over there in the northwest, and you can see it's pretty low. I'm going to use my zenith coordinates right now. It's about 24 degrees above the horizon. We're going to give it a shot anyway. It won't be as good. It's not that good over in the Sonoran view either. But we're going to come over here now and start up our connection if I didn't already. I don't remember if I did it. Didn't. Okay. Now we'll connect. Alright, so now our telescope in Benson is now connected, and we can tell it go there, and you'll watch the telescope go through some movements here.
In the stellarium view there, you see Mars, and that's Regulus and Leo to its lower right. They had a very close conjunction a week or so ago, and the clouds actually broke. I got to see it that night. It was beautiful to see. Mars and Regulus were so close together that I could cover them both with the tip of my finger held out at arm's length. It was a really nice conjunction.
Wow.
And since then, Regulus and the rest of Leo has continued heading toward the sunset, and Mars is still trying to keep up with Earth as we both orbit the sun. Mars is slowly losing ground, but is doing his best to keep up. He'll be up there for a while yet. So anyway.
I'm going to do a 3-second, let's try a 4-second exposure. Get a few more stars and see if I can have it tell me where I am. Because it may, see, we need to focus too. I don't think it will know from this. It may not be enough. Okay, not enough yet. It's not quite dark enough out there.
Well, bummer.
No, it's okay. Give it a shot. If we go to Stellarium, okay, you'll see that we look to the west and it's pretty dark now. So there's just a faint light left over. We can actually go to a different star field. And let's try and, yeah, you see that? How that's changing like that? I wonder if those are, I don't think they're clouds over there.
Mark,
I don't want
Donald Kunzer says you sound off mic.
I do.
What he
All
said.
right.
Difficult to understand you.
Interesting, because I
You,
am using the same mic I have before, so I have to check that.
you sound okay to me.
Okay.
But then I don't know if that's because I'm talking to you through Teams.
Okay, how does this sound? Did I improve? I just changed it. I just changed the settings. I think I may have. Thank you for that, Donald. I think maybe I wasn't uh, on the right thing just now. I wasn't on the right setting. But I think I am now. Let me know.
You sound the same to me.
It'll sound the same to you.
Marianne says you sound like you're in a tunnel, a little
Yeah,
scratchy.
yeah, that's interesting. Cause okay, yeah,
And she
she
says
came
lots
in.
better.
Yeah, she came in and put that comment on just before she actually heard the change. I actually selected the correct microphone. It was actually going off the microphone of my webcam, which is terrible. Okay.
Donald says you sound better too. So
Excellent. Much better. Thank you, Donald. Let me quickly go and look at Windy Satellite, see if we've got anything in Benson right now. It doesn't look it. Yeah, we're gonna. Maybe. Yeah, there might be some high clouds. Actually, I can do better than that. I don't know what I'm thinking. Let me just come down here and refresh my all sky that I borrow. Oh no, we're actually good right now. Oh, but look where the moon is. See around the moon in the west?
yeah,
Yeah, that's where we are. So we're looking at some clouds through there. So there's some high clouds right here. Okay, this is a reflection from the moon. Okay, so this one's out, Daryl, for tonight. Cause look at this. These are supposed to be regular
well.
stars. That's
Yeah.
okay. Let's come back to this. It's very low at the
You're
horizon.
yeah. Well, it was high up when we started.
Higher, yes.
Yeah. Well, higher. Yeah.
Yeah.
So that all sky we just saw, that was Sonora.
No, that's Benson.
Oh, you have
It's
an all
not.
sky at Benson now.
Well, I have access to one. It's not mine.
Oh.
I'm making one for Benson, which is going to be different. Okay. It's going to have a lot more information. It's going to be quite a bit more complete.
Donald Kunzer says, Mark, did you see the Nova in Lupus?
You know what? I wanted to see the Nova in Lupus, and every time I tried to do it, I couldn't. It was cloudy, or I couldn't get to it, and I mean, I can see it perfectly fine from here at Benson. I just
Really?
haven't yet,
Huh.
and I think
I
I
thought
don't
it
know
was
if it's still there.
too far south.
No, it's visible from where I am in Benson.
Okay. Hmm. I don't.
Okay.
I haven't seen anything about it recently. I didn't think it was very bright.
It's not.
Yeah. It's a
Okay.
nova, not a supernova.
Correct. I'm going to see which way I gotta go here. All right. The telescope was only just open, so it's still acclimating. So I'm going to be bringing down the focus here. You can see some wind actually, as you can see, affecting things out in Benson. That looks pretty good. I'll dismiss that. Okay, let's try this. Let's do a... first of all, see if we can figure out from these few stars whether it knows where it is. It probably won't. It needs stars to figure it out. Okay, so next we'll do is this. We're going to say a 5-second image. Okay. And in 5 seconds, we'll see the result. Okay, still not enough. As you can see, that last 5-second photo was not very good. Okay. Oh, there's a bright star up there. Interesting. We got wind, as you can see. The wind is what's blowing that around right now. Let's see if we can still eke out an image here. It's hard when we have wind going on. All right, so it knows where it is. It's going to re-sync, and it's going to bring us to this galaxy that we just tried to find. Oh, and I'm doing 5-second exposures. There it is. Okay. And this is going to be, now we're going to look for guiding on this. This might be less successful because we do have issues with the wind. But we're going to try it. So let's tell it to grab some stars. That's not going to work. So let's stop. This is, for what you may recognize it, is the Black Eye Galaxy. Okay, so let's...
I was going to say.
Yeah, there we are. Okay, so apparently, all right, we have our stars. So what I'll do now is let's hope that I'm going to take this all to 2 seconds as well, because you do want to make sure that we don't lose any of the image. Okay, so being that we have some wind, we're going to still try this. All right, and I'm going to do a 20-second shot. Let's try that. And immediately that's telling me that it's going to be tough. Okay, we're giving it a shot. Don't worry, we still have this telescope over here to check things out with. That's a wide field. All right, let's live stack this. So we're going to come out of low light mode and go into deep sky mode. And let's see what we got. Oh, look at that. That came out nice. That's pretty. Okay. And so that is the Black Eye Galaxy, named for this abundance of dark matter and material. Not dark matter, but dark material on this side as seen from our perspective.
This is Benson, or?
This is Benson.
And remind me what the Messier number is?
Messier 64. Okay, right there.
Yeah.
Black Eye Galaxy. We'll set the target name. We'll save it with the annotations. All right, so we got one and it rejected two, so we have some wind going on. All right, let's go here and see if we can get away with... yeah, see, the wind's causing these rejections here. If I chose not to do this guiding like this, then we would end up seeing a much more clean image. But we'd see all these images. The trouble is they would be pushing a lot of stars out of focus. So I'm going to raise the threshold to 12.97 and see what it does to our stars. If it still comes in as a red underneath that threshold, it means that the frame was not good.
Your prize is not bigger in the Benson scope.
Oh, you should see it in the other scope. It's the size of the nucleus. Yeah, okay, so we're doing that. Let me go to stacking. Let's see if I can. If I raise this limit, is this gonna do anything? It did before. Let's see if I can. Okay, now I got a warning from this. The wind blew us out of ability to capture right there. Yeah, okay, we're getting a lot more wind. All right, 3.54. What's this one? Okay. Let's see if that made a difference.
Would you believe summer has just started like a week ago, and
Yeah.
Antares and Scorpius is already west of the meridian by local midnight.
Yeah, that's true. Well, I'm going to save this anyway, just to have it. But this is not doing what I wanted to do. So, I mean, that telescope is a giant flag sticking up in the sky, so it's actually subject to the wind. So this first one should come in. Because the first one always does. And these go way over there. And there's our black eye. Let's see if we're going to get any additional ones here. Yeah, we got the second one. That's good. Okay, so we're off to a better start now. Okay. Now the thing you'll notice with the black eye galaxy is you immediately get color in here as soon as we get the last one. Or sorry, so now we got 3. So I think we're on a roll right now. I think the wind has died down. So as we get moving here into these exposures, you'll see that the data becomes clearer and clearer and better. So we can start to zoom in now to see some of the detail in here. We can increase the detail a little bit by doing a push, which is this, but then it makes us the unfortunate noise, digital noise, comes into play. And so I move this down to remove the digital noise, and I'll zoom us. That way we have better control of our data. And this is our black level. If I move it too far away, then we get artificially induced brightness. But if I pull it here, the peak of our data is here. So technically you would never go beyond this, because then you would lose data. But I tend to go just shy of that peak because there's faint stuff on the fringe that can get lost. Okay, so I pull that in there. By the way, just a little aside, today I actually I have a new streaming station coming. The stuff starts arriving tomorrow. Not the computer. The computers that I'm using, these are fantastic. Very, very high end. But the desk and everything that hold the monitors is going to be different. It's going to look like a spaceship when we're done. Only because it has to. Because I've got several monitors in here. Okay, this big curved one in front of me here that you can't see is, well, actually, you probably could if I were to turn this around. Well, I'd have to, you know what, I can do that in a bit. But if you look at this particular, what?
Never change, Mark.
Yeah. Yeah, I tried it before. I should have. The problem is that this station I'm working on, this table, is almost falling apart. It's been going for about 10 years. And it's on wheels, big wheels, which is nice. But I bought another one that's going to be much simpler. and I have a big monitor stand which will allow for both the monitors I need, the curved one and the flat panel, which is to the right, which has the broadcast software on it. The observatory stuff is right here in front of me, and that's the thing that I'm looking at now. I have a cloud coming to Benson right now. I see it. We may have to close up Benson shortly, but that's okay. We'll get this out of it anyway.
It's actually shaping up nicely.
Yeah, isn't it? We got 12 shots right here, so we'll save that and save it exactly as seen.
You can kind of see a light halo all the way around
Right here, huh?
the nucleus and the dark cloud.
Oh, right here, you mean?
Yeah.
Oh, right here. Yeah, you got this little... Yeah, that's really pretty.
Kind of an almond shape.
Yeah, let's zoom in on that. Yeah, this gives us some really, really nice detail. Very pleased. I will say this telescope has not disappointed us. And I mentioned it to Daryl before, but I'm not going to say where yet. But, although Daryl knows. At the end of August, I'm going to be looking at a third location because we've been invited to look at a possibility of putting a telescope in a third location. It's in the United States, but it's actually a darker sky by one whole order of magnitude.
It's in the largest alpine valley in the world, so they say.
Well, and I know that also means wind, so we might have worse situation there. I have to gauge it all and see if it can work, but I'm not going to tell people where it is yet, because I don't know yet. Yeah, I don't know yet, but that's okay. You know,
It's an old Spanish land grant is what it is.
you keep giving hints. It's a big place, right? So obviously.
Oh, yeah. Big sky.
Yeah, it's big sky too. Yeah, and I'm looking forward to it. Look, we got 2 rejects here. Are they the last 2? Oh no, good. So it's actually not the last 2. There we go. All right, good. So 17. We'll go to 20 if we can. But I want to show you. Let's zoom in even more. Look at that galaxy. Now this is as I mentioned before, this is the Black Eye Galaxy, and it's actually over here in the constellation of Coma Berenices. Okay.
Bernice's hair.
Yep. And it's actually a beautiful galaxy that's about 24 million light years away. So the image you see coming from it here is 24 million years old, which is kind of cool.
Bernice's husband went off to war, and she offered up her beautiful long hair as an offering to ask the gods that her husband come home safely. And he did, and they liked it so much they stuck her hair up in the sky.
However, he didn't relish having a bald wife, so he divorced her.
That's not nice.
I'm kidding, obviously.
Obviously.
You put her hair up there, you know. All right, so we got 21 shots now, and that's all good. And I can see we might have some clouds interfering, so I'm going to stop it here. Okay. And come back to our low light mode. All right, like that. Okay. Yeah. Yeah, I see. We have a cloud bank coming in. All right, so let's drop back. We're gonna fit the height. So this is our full frame. It's about 33 arc minutes across and tall. It's a square sensor. Okay, perfectly square. So it's really nice. All right, let's see if we can eke out one more. I doubt it. Or maybe southwest. Maybe we can look at M53 real fast, since that's right nearby. See if we can get that one. See the telescope moving right there. And we are lost our guide, of course. And there's the guide. There it is. There's the globular. It's beautiful. Okay. All right. So let's just move it a little bit. Do this right here. Oops, wrong way, Feldman. The other left. That's west. Okay, so this is good. All right, so now what we'll do is we'll get our guide star. And looks like we have a couple choices. We'll do a 2 seconds. There we go. And now grab it. It's probably going to grab that one. Yep, okay, good. We're guiding on it. All right, so this is good. This is measure 53. If we come in here, you'll notice that it already knows, because if we only move a few degrees away, it knows just what we're looking at. Let me just say nearby. Okay. Oh, interesting. Well, we know that's where it is. Okay. So I have to take an exposure first. All right. So let's come out of this. Okay, we're guiding fine. And we'll go over here. Let's do a 20-second shot. We don't need much for measure 53. It's pretty bright. It is a globular cluster. These are halo objects. They surround our galaxy and they kind of orbit the whole galaxy as a whole. And when they orbit the galaxy as a whole, that means they can cross through the disk of the galaxy and then come back up through the disk of the galaxy. So they could shed some stars and gain some stars if they get close enough to other stars. Look at that beautiful cluster, Daryl.
Uh-huh.
That is really pretty. Very, very happy with that cluster. Really nice. Let's see about zooming in a little bit. Yeah, look at that.
Yep.
Oh, very nice. Let's see if the star colors are good. And they are.
Every globular is different, has its own character.
Yeah, like a fingerprint, right? You know, it's really interesting. I want to, yeah, we got 3 taken so far. This is good. I have to say, the other night, I was taking some pictures of my own because I wanted to see what the capabilities of the telescope were, especially since we're not at the full focal length, but at f7, which is significantly different from f10. And at f7, I went to a well-known double star, which are 2 stars next to each other, and 2 stars and 2 stars. So, and that's called Epsilon Lyra. And it's in Lyra, of course, the constellation. And splitting the double has always been something that the Sonoran telescope could kind of not really do because it was so wide angle. But this telescope had no problem doing it. And I was very impressed with that. So clearly, this is a good thing. You know, the telescope is performing very well.
Speaking of, looking at the 2 telescopes over on the left, It was very dark in the Benson Observatory. Now it looks very bright. That's not visible light, is it? Is that infrared or something?
Yeah, that's all infrared.
Yeah.
Yeah. Now, I will say this. When we are using a spectrograph in there, we're going to have to be careful about pointing the telescope at the walls a little bit because the light will affect the sensor, the spectrograph, the spectral response. So if we're doing real stuff, like I have ours on the Las Cumbres telescopes, which is a network of large observatory telescopes around the world. We have like 50 hours, and we're going to do exoplanet searches with a team with Mart's Cole Observatory and a bunch of others. And if we were to use our Benson telescope to do research stuff, we have to be very careful about the amounts of light we let in, because the telescope's infrared. The infrared bleeds a little bit, tiny bit, into the visible spectrum, and we don't want that leakage to show up as a false reading in the spectrograph. So I have yet to figure out what I'm going to do here, because this telescope has an infrared system. Okay, I'm sorry, this camera that I'm using here at the top has an infrared, and this one has infrared. All right, and if you notice this bright thing right here, that's the light that's causing this illumination here. That's the infrared transmitter. So we have to be careful about that light. Look at this. Look at this. This is beautiful. Coming up on 12 exposures of Messier 53. Very nice.
It is nice.
Yeah, I'm going to save that. The telescope is stabilized temperature-wise, so now our focus will remain pretty much the same. I noticed too, Daryl, that this particular telescope doesn't seem to have the mirror flop issue that we have with the Sonoran telescope. If you change the position of the telescope, the focus changes a little bit because the mirror is actually moving a fraction of a millimeter. This telescope doesn't have that problem. So once you get the focus, it stays, you know.
Cool.
Yeah, and you also do have to allow the telescope to acclimate to the temperature, because right now out there it's 33.5 degrees Celsius in this building right now. So that's still pretty warm. Okay, we're going to come up on our 15th shot, and we'll see if we can move on to something else. There's 15. Beautiful, beautiful. Beautiful, beautiful. So I have to make sure I set my target name here. There we go. Yeah, I guess I saved it in the wrong spot, but no problem. I'll do it again. And I'll clean it out later. Okay.
I've owned Meads, and I've owned Meads, I've owned Celestarns. I'll take a Celestron any day of the week, thank you.
Yeah, well. Okay, so that's good. That's really pretty. Let's see if there's any other stars lurking out there. Let's bring this in. This is our mid-level. This actually picks up faint stuff that might be on the fringe of visibility. Hey, not really. I think we got most of it. And these globulars have, like 100,000, 150,000 minimum stars in it. And sometimes many more. Okay, let's take our 18th exposure here. We'll do 19. Alright, well, I guess I'll just let it go to 20. Meanwhile, while we're waiting for that, let's go check out what else is visible to us right now. We have Virgo, okay, and we got lots and lots and lots of galaxies in Virgo for sure.
That Sombrero there right next to Spica.
Yeah, we can go look at that. It's actually bigger here. Alright, so we're going to save this now and save exactly as seen. Is that M104?
Yes.
Okay. All right, so we're good there. And if you're wondering where this is, it'll be at skytourlive.org. You just go up there and look for the Take Me to Cool Pictures, and you can go and download the pictures. We're back looking at our app. We've got someone to help us doing data entry along with Isabella. And hopefully that will kick off fairly soon. And we have some catching up to do. All right, so over here, let's go back into our beautiful planetarium here. And I want to... That ain't it, is it? Down there? No, it's not there.
Just west of Spica.
Yeah, there it is. I didn't go far enough. Okay, so now we're going to go watch the telescope move. We're going to head west, young man, to this location right here. Here comes our telescope. And there's our sombrero. Where was it? I saw it there for a moment. Okay, let's go over here and shut down our guiding. We don't need guiding. What's it following right there? That's interesting. Maybe it was following a UFO. Ooh. Let's do this. Get another photo. Oh, I can still guide on that guy if we have to. Okay, let's see. Does it know where it is? And if it does... It does not yet, but I can help it along by doing a 5-second exposure. And those additional stars might be enough to help it figure out where it is. Or not. Let's find out. Okay. Doesn't know. Oh yes, it did. Okay, so that means that I can now plate solve and resync. Oh, come on. It knows where it is. It could be because the telescope isn't actually quite focused after all. Interesting. Let's try this. Alright, let's come out of here. And let me come back to this. Let's move. Go to 1 second again.
Have you synced tonight?
Yeah. But things change dynamically here. Whatever it is. I'm trying to figure out where this is. It doesn't have the ability to... M104 is just out of view. Okay. That's very helpful. Just tell me which way out of view. Alright. Let's try this way. Alright, and maybe focusing a little bit. Okay. That's not going to know it, but we can try this. We can try an 8-second photo and see whether that gives us enough stars to do this. We only need one hit. Okay. Stars are not in focus right now. Let's just try this anyway. Unless we're looking through clouds.
That was
Yeah.
what I was wondering.
Yeah, we're gonna go there now because it got it. So the next view it comes up with will have there it is. It looks a little bright. So let's see. Oh yeah, in Benson we do actually have. Well, I'll tell you what. Let's go instead of messing around. Let's go actually look and do this. Well, there's the Milky Way. I don't see clouds. We're kind of right here. Moon is setting. Okay. Well, I am happy about that. Okay, so let's move this up. I'm gonna go back to this 1 second low light mode. Okay, and do this, and now I can bring us up here. There we go. Nice. Let me try going to this positive direction here for a second. Okay. Okay. All right, let's try that. Let's do a 15 second shot to get started. We'll go out of our low light mode and go into our deep sky mode. I think I've been kind of, not meaningfully, but I think I've been sort of not paying attention to the chat. Dolly Saffron, hi. Nice to see you, Dolly. Here we go. All right, so there we go. We got our guiding going. There is the galaxy. Hello, Otto. How you doing? Dolly, you have a podcast? If I recall. Am I correct? Let me move this over now. Let's bring this up to just the edge of our data, like I said, like I like to do. Oh yeah, see that reddish view? Yeah, there's some light clouds that aren't showing up on the that aren't showing up in the all sky. The all sky is actually not very sensitive. The one I put in there is going to be very sensitive. Friend, would you like some spike and flame gems? Not today, Harry. Okay.
Oops. Would you excuse me a moment, please?
Yep, go right ahead.
Be right back.
I'll be right here. Yes, Dolly has the light gate. All right. Is that with Preston? Tonalo says, I love seeing edge on galaxies. Yeah, this is edge on. The detail's not as good tonight because we are looking through some light clouds. But that's what happens, you know? That's what happens. In this other observatory here, I've been taking a photo for quite some time. You know? Yeah, Preston Dennett is on there with you. That's what I thought. I'm not sure. Did you ask me to be on that podcast? I think you might have. And if you did, I think I responded and said yes. And I'm trying to remember. Tubular mind wave. Any aliens? Not tonight. So far, we don't even see satellites. So that's kind of weird. We haven't had any real satellites go through. That's strange. Okay. All right. Yeah, this is cool. Cyrano Jones from Trouble with the Tribbles. But Kirk, they're so lovable. The Tribbles, remember? It's purring, Uhura said. Scotty, what you do with the Tribbles? I did like you asked, sir. I beamed them over to the Klingon ship where there'll be no trouble at all. Dun 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 dun. Great episode. Okay, let's peek up our data here. That dark line is from guiding. Let's go back to our guider. Oh, well, I guess it would have helped if I was guiding. It's guiding, but it's not doing exactly what it should be. So now it will. It actually did a good job without the guiding. Otto asks, are you using any kind of filter? Yes, sir, I am. If you look down here, okay, you can see I've got several filters. I have a radian filter, which is kind of like 2 of the 3 narrow bands, the H2 and the oxygen 3. UHCS, kind of a wide set of narrow bands all in one. So we get H alpha, oxygen 3, which is doubly ionized oxygen, and sulfur 2. I have the SA100, which is a spectral grading, which allows us to see the colors of the stars, which I should spring on you. I should show you one of those at least. Okay. And we have a dark frame collector, which is actually a disc which blocks the opening so we can do dark current. Then we have an open where we can just take a view without any interference. So the slightest bit of light from anywhere will cause it to be extra bright. Okay. Yeah.
Okay, I'm
good.
back.
Welcome back. All right, let me stop that part and reselect my stars. Okay, let's do that. Oh, it didn't get it right. I'm gonna pick my star right there. Oh.
Dolly,
Let's do this.
Betelgeuse isn't up right now. Betelgeuse is in Orion. It's a winter constellation.
Yeah, it just went down.
Say what?
I said it just went down after the winter's over.
Oh.
It's already set. Okay.
Orion is a winter constellation. It's if it's visible at all right now, it's in the morning sky before sunrise.
We definitely got clouds. Look at this.
Uh,
All right. Well, tell you what, we'll come in here and we will just select it and then save it with annotations for now. Save it. It's high altitude clouds. This fuzz here, dead giveaway. We always see that with this. So we'll save it and save it exactly as seen. Okay. And let's come out, go to our low light mode. All right. And while we're in the neighborhood, let's go over to the other telescope, 200 miles away, and let's go check out this galaxy. Now, we've got 123 images taken of this galaxy because it's been sitting here cranking away slowly. And we're going to set this in. There we go. And let's color correct that. All right, look, now you can see the spiral arms. That galaxy is very low. If you look at it, it's literally, this red is because the telescope's touching the edge of the building, not touching, but it's impacting it. So we're done with this one.
Is this still 3344?
Yeah.
Huh.
Yeah.
I figured it would have
It's very
set by
low.
now.
It's almost set. Yeah. But we have
But you
a
can-
larger western horizon with this.
Huh.
With the Sonoran telescope. Okay. Now let's go back to our 1 second in the Sonoran telescope.
Imagine how that would look in the Celestron.
I know we couldn't get to it.
Yeah.
Yeah. You know what we could do? I don't know what it looks like, but we could try M100. M100 fills this whole frame in the Benson telescope over here. Fills this whole frame. Should we try that? If we can see it?
You like? Sure.
Sure. Let's go do it. Anything to try and capture something. It's M101, right? I believe.
You said M100.
Yeah, I meant M101.
Oh, well, yeah. Sure. That's a big, beautiful galaxy.
Yeah, it's close to being up there.
See, it almost makes a equilateral triangle with Alkaid,
Yeah.
and these are. That's the two end stars in the handle of the Big Dipper.
Mm-hmm. Okay, well, here we are. Let's see if we're there. I guess we'll find out. And I can stop this right here. Reselect stars. Okay. And I'm not sure that we have it here, but we'll find out. You know, there's some days, some nights when the telescope is right on the money, and other times when it's not as accurate. And I haven't figured out the difference. But let's do an 8-second shot here.
Have you synced it tonight?
Well, you already asked me, and I said I did. Yeah. I'm doing it. There we go. So it'll know where it is here. So let me plate solve and resync. So I've done plate solve and resync, so you'd already found it. So let's see how far it moves. .42 degrees. Okay. Well, there's the center of the galaxy, and this stuff out here that you see, this fuzzy stuff, these are all spiral arms of this galaxy way out there. And it looks like it's not in the clouds, so I think we're going to get a nice shot here. Let's go here, and let's stop the guiding, and let's do, I think we're going to get some stars here. I do want to check focus too, so I'm going to do this. I'm going to go positive for a moment. Oh, we had an 8-second exposure, my mistake, sorry. Let's get out of that for a moment. All right. Okay, so now let's do a 25-second shot. And first things first, we come in here and get our guide star. Yeah, okay, these are too bright, but I'll pick one Let's see if it can stomach that one. It wants a small guide star, you know, it's not very bright, but let's give it a shot. Alright, 25 seconds. Let's go into our deep sky mode here. Wait till you see the sheer size of this galaxy. It's just incredible. Very large. Do you know what the arc minute size is of this galaxy, Daryl?
Not offhand. Give me a second to look it up.
Alright. Let's do this. Oh, look at that galaxy. Yeah, we got some wind distorting our view here. So we're gonna clear that and hope we get a better shot next. Okay. Yeah, we got wind going on, making it hard to see. Oh, actually, it's too bright. It's definitely
M101,
like clouds. Yep.
M101 supposedly is 28.8 by 26.9 arc minutes.
Okay.
So that should pretty much fill your field.
Mm-hmm. Yeah, it's too bright. We got clouds up there. That's what's going on right now.
Huh, pity.
Yeah.
That would make a pretty view.
Yeah. See, when you drop down this value, you're like looking through a curtain at this, and it shouldn't look that way. It should be a dark sky. Like when you color correct, you get red, and that red is actually from the clouds. So unfortunately, I don't think that's gonna work to look at M101 tonight, unfortunately. Well, sorry about that. And the guider is actually kicking off, saying it's not guiding anymore. Yeah. Yeah, Vera Rubin telescope is the largest camera in the world. And the images look so fantastic.
Yeah. Oh, that image of the lagoon and the trifid was just too much. I think I mentioned in team that the native size of that image is like 55,000 pixels across by 30 some odd thousand tall or something of the sort. It's a huge image.
Yeah.
But that's what the world's biggest camera is for.
Yeah, that's right.
It actually has a field of over 3 degrees wide, if I remember right.
Yeah,
3 or
something
4
like
degrees.
that. Yeah. Didn't have to do a lot of stitching. You know? Well,
And
let's
it's
see if we can...
It's fast,
go ahead.
too.
Yeah. I'm going to come back to that in a bit. What I want to do is actually take us back to our eastern, or the westernmost observatory, which is actually the Sonoran, in just a second here. But first, I want to look at this. Yeah, see, it's unable to continue getting frames here, and most likely it's gonna say it can't align. Let's go look at the log. It'll tell us the last. See that little one there? It's gonna say can't align. All the way to the end. Could not align. See? Okay. Not being able to align is because it can't see. It can't see the sky. There goes one satellite for the first time tonight. Yeah. So, what we have to do is figure out what's going on with the sky tonight. Let's refresh this. The Milky Way's up pretty high right now. But, you see this glow here? That's showing that there's light clouds all across the sky. Because normally you don't see anything except a very, very little bit down here. You see how you see those lights there? Okay,
Oh,
25 miles away. This glow you shouldn't see. But we're seeing that glow because there's light clouds here. So that tells
maybe you
us that
should
this
look over to
telescope...
the east.
Well, yeah, and so what I was going to say was if we actually go that direction toward the east, I think we'll be better off. We could try, in this telescope anyway, we go to Canis Venatici. Lots of galaxies there.
Michael Hedrick has a question of you.
Okay, what's he asking?
He says, Mark, can you address a query of mine for a moment, please? So how many more galaxies could fit in the universe if we packed it all in 10 times more?
How many? I'm not sure I even understand the question. I guess I should have been listening closer, Michael. I'm sorry. What was this question again? I'm sorry. Northeast, east.
Let me expand chat a little bit. It's running off the edge.
Okay.
How many more galaxies could fit in the universe if we packed it all in 10 times more? I guess if we say we compressed it by a factor of 10, is that right?
Well, okay. Then maybe we're talking 20 trillion galaxies. Because it's basically, right now, it's like approximately 2 trillion galaxies besides our own. So it's a strong possibility that what you're going to be talking about is 10 times that. And so it'd be like 20 trillion galaxies that you might find yourself looking into.
That reminds me of something. Have you heard, among all the stuff that the Webb telescope is supposedly breaking cosmology, some are saying now that the cosmic microwave background is not the cosmic microwave background at all. It's supposedly all the light from the early galaxies back closer to the Big Bang, I guess you would say. We got Dumbbell.
Yeah. I'm reaching for the dumbbell tonight, yes. Let's see how it looks. I want to see if I'm in a cloud-free zone. And if I am, that's a good thing. You can see the white dwarf in the middle right there already.
Yeah.
Alright, let's go. We'll have plenty of stars. Oh, we're not in focus, I can tell, because this camera should be in focus. Let's see if... Yeah, okay. Yeah, we still gotta focus, okay. I'm gonna do that. Not a problem. Alright, and I'm going to do a 3-second focus run, where I'll do it at 3-second intervals instead of 1-second intervals. And I think I want to go negative here. So it's gonna cut over to our focus mode. You'll see it in a second show up. Yeah, look what wind is doing. Oh man. Well, it's skewing our results.
Otto asks about the fireworks galaxy.
Oh yeah, that's a pretty galaxy. That's like a face-on spiral.
Yeah. It's right on the border of Cepheus and Cygnus. Is it too early for that?
Little bit. It'd be very low. So it
That's
wouldn't
what I
look all that
thought.
good. Yeah. You can see as we approach focus here, we're capturing these different stars. We've got 17 stars that we're using. It's going to make a curve down here. And that curve will eventually be like a parabola. And the vertex, the bottom of that parabola, which is a calculable quantity, will be the location where perfect focus is achieved. And it may not be one of the stops along the way that the telescope is doing. So it may interpolate where it is. It's not going to cross through. That's a perfect focus right there. Yeah, 19,780.
Can
What's
I
that?
expand? Can I expand a bit
Yeah.
on? Michael Hedrick was asking about Vera Rubin,
Yeah.
and I said she's sort of discovered the dark matter. It's not so much that she discovered dark matter because we still don't know what it is, if it even exists. But she was the discoverer of the rotation rates of galaxies, the stars and galaxies. What you talked about before, Mark, where the stars in the outer part of galaxies are moving faster than they should
Mhm.
to account for the mass of the galaxy.
Yeah.
Therefore, there is missing mass that we don't see, and that's where dark matter comes in. She
Yeah.
discovered the rotation rates of the outer stars versus the inner stars of the galaxy, and the need for dark matter, so to speak.
Yeah, actually, dark matter was the postulated possibility. There's our focus point, guys. The bottom of the parabola right there. Focus curve. So I could just say best focus and it'll go to that spot and focus. Takes care of the backlash into focus by running through like that. And then it comes back and does that just to make sure. All right. And then when it comes back, it'll come back to there. Okay. And then I can get rid of this. All right. And we can move it over. Okay. This is a 3-second shot, by the way. So once it gets there, I'm going to come in here and redo our stars because they'll be different from the last shot. And you'll notice that they're going to be in better focus. And they are. And then I can now select them and we'll get our guide stars that are nice and bright and perfect. Okay, now let's go explore the Dumbbell Nebula. And for this, I'm going to do I'm going to give it a shot. Try a 30-second shot. I could do 10 minutes, okay? And there's outer halo of this object, which is just gorgeous. But I'm not gonna make you sit for 10 minutes to see one photograph, okay? So we're gonna come out of our low light mode here. And again, there's that white dwarf. White dwarfs are pretty hot, you know. So we're gonna come out of here and go into our low light mode just in time. And there
I noticed that image you did recently of the Ring Nebula on the server. You can see the white dwarf in the center of it. Had we seen that before?
On the other telescope, it was very faint, but we could see it. And on this one, it's a little better. Now, you'll notice I got to take this mid-level and move it way down. Okay. And by doing that, I still have to go further for the white dwarf to show up. Okay, so when I come down way down to here,
I
now
can
you
see
see
it.
the white dwarf. Yeah. And you'll notice also that you see this outer stuff, right? That's the outer structure. You can see more out here. The more that we darken it, you can see it's all the way out here. This is an extremely elaborate planetary nebula. So if we go like this and we say that, well, now you can see that's a Dumbbell Nebula. We're going to make that the target name. And we're going to save this image with annotations because that's already a good shot. Okay. And that will show up on the server too. So when you go to skytourlive.org, if you want to download this picture, have at it. You'll enjoy it. Let's see what else is in here. Let's overprocess. Watch this. So we overprocess, and you can see there's more subtle blues out here. Look way out. My phone is saying, "What do you want?" I thought I said, "Hey Siri." Okay, there you go. So now you have this way out here. You see that arc? Yeah, and there's one out here. All right. Really something. And you got red nebula also around this as well. Let's color correct just to fix that. All right, and then we can undo the overprocessing. Okay. Look at that. So this really looks beautiful. This comes out really pretty. Let's come up just to the left of our curve. Whoops, sorry. It didn't let go when I let go. There we go. All right, and then we come over here. That's our white level. We're going to move that way over. Way over. Okay, I should actually be way over. Should be all the way over. Actually, I'll do it this way. There we go. Okay. All right, and there's our mid-level. And
I still think
curve.
If there are like axial jets coming from the white dwarf, you can see them at about a little above 9 o'clock and just below 3 o'clock, and it's like where those red areas are the hottest, the brightest, and like the orbital, the spin tilt of the white dwarf is precessing.
You talk about this line here.
Yes.
A little below that.
And then the precession would go to the other end of the red at both the at 12 o'clock and down close to 6 o'clock.
Yeah, that's what we've talked about quite a bit, I think.
Yes.
That maybe it's going back and, it's going, as it's precessing, it's going around this area. So the stars, it's actually doing this. If you look at me in my picture down here, you can see it looks like it's doing that long term, wobbling on its axis, kind of like the Earth does when it precesses. But a star doing that is emitting these jets, and so those jets might be polar jets off its north and south pole, and this is the equatorial regions getting spread out and mixed up as it goes. That's very, very possible. Let's zoom in a little on this now. This is a gorgeous shot. Look at that. It's definitely a keeper, isn't it? And notice the color. It's not blue, it's not green. It's sort of a cross between them. That's doubly ionized oxygen. And it's represented as O for oxygen, but then the Roman numeral 3, that's III. And the reason is because in the base state, all atoms are Roman numeral 1. So hydrogen 1 is an atom of hydrogen that has a proton and an electron. Okay? When you actually ionize that proton or ionize that electron off the proton, and now the electron leaves the atom for a period of time, that becomes H2, Roman numeral 2, II. All right? So we have to remember that the base state of all atoms is Roman numeral 1. So if a doubly ionized oxygen atom is being shown here, it means that 2 electrons are knocked off, not 3, which is what is confusing. All right. So there's the white dwarf. You'll notice. Well, go ahead.
Go ahead.
I was going to say, notice the white dwarf. Let me just dim it down a little bit and zoom in, you can see the color of the white dwarf is distinctly different from the colors of the other stars. You'll notice that it's blue, and that's because the temperatures of the hottest things in the universe are blue, and white dwarfs are exceedingly blue, and so their temperature is very, very high. Therefore, their color is very, very blue. Neutron stars, similar. Wolf-Rayet stars, not quite as hot, but still similar. So yeah, this is gorgeous. And one of the things that we haven't noticed before, and this camera picks it up beautifully here, is down in here. You see all this detail down here. See that?
Yes.
A lot of detail in this red stuff. You can almost see radial motion here of the precession through the center. So this thing just is going back and forth over time, or going around and around, making this hourglass shape, and spewing stuff off equatorially like this. The other thing too I noticed in here is that we have this blue out here, and there's like a little reddish glow as well. So there's more hydrogen being ionized out here. You know, really interesting. I'm gonna try something here. I'm gonna drop this down a little bit. Now, if we did this in black and white, this is what this would look like. That's what the Dumbbell Nebula would look like in black and white. That's what I'm used to. When I was younger and taking images, when I was getting my degree in astronomy, many of our images were black and white. And we didn't have the need to use color. Color only showed up later for pretty images. Okay, and so in this particular case, we don't need. In this particular case, we need pretty images, but we don't for research. So research is seemingly a bit more boring because we don't have the same requirements to capture objects, you know, with full color versus black and white. 17 images captured here so far. Look at that. That's really pretty.
I've always wondered too, if you see the red arcs and then after they turn green, like over at 9 o'clock and 3 o'clock, you see that brighter line continuing along that sort of an eye shape. And like the corners, yes, the corners of the eye are there at about 8 o'clock, and then up at the upper right at about 2 o'clock.
Mm-hmm. Yeah.
That it's like a shell inside there.
Yeah, it is definitely. I think that's the equator that we're seeing, the equatorial outflow.
Yeah, where the 2 points are at lower left and upper right.
Yeah,
that would be the equator of the star, equatorial plane of the star.
Yep, that's my assessment as well. So the equatorial plane is like through here, okay, and the North Pole of the star is kind of through here.
Yeah,
like that. Yeah, and so it's spinning this way, right? I mean, it's spinning out of the page, into the page, out of the page, into the page, out of the page, into the page. Yeah, something like that. That's what I've gathered from looking at this. Now, is that really what's going on? I'm not sure. I gotta look at the studies of radial velocities in the clouds of Messier 27, and we'd know that answer. What would be really surprising is if this is an equatorial outflow. It's possible, but precession would still cause some of that if it was doing equatorial outflow, but I still think it's the other way. I think that these are north polar jets up and down. And this particular type of nebula is called a bipolar nebula. that's not a personality comment. It's actually a comment based on the fact that it has a predominance of features in one direction and then the opposite direction. So north and south, for instance. So bipolar meaning the shape is such that it's not uniform all the way around. It's different here, different here, different there, different there.
Michael Hedrick has another question for you.
Okay, let's go see Michael Hedrick's question. All right, Michael, what you got? He's saying, another question. Do we know if certain places like this nebula would keep planets from having any moons? Or is there any
No.
situation where planets could be kept from having any moons?
Yes.
Yeah, we don't know for certain, Mike, as Daryl just said. But the thing about moons is you need to have a relatively stable solar system to allow, or star system, to allow for moons to form and to allow planets to form. And around a very, very hot star, it's possible that you might not get either of those things, because you might have planetary systems that may have formed if it wasn't for, say, very, very powerful stellar winds which blew away all the material that could form planets. And that's a possibility that might have happened in such a star system.
In this case, Michael, this is a planetary nebula. It's basically the star at the end of its life. Sun-like stars like our sun, will ultimately probably become planetary nebulas with white dwarfs also. What that means is all the planets and any moons would have formed a very long time ago. So in this case, a planetary nebula would not preclude moons because it would not preclude planets because they were there before the planetary nebula was, billions of years before the planetary nebula was. Then, as Mark said, in the case of big hot stars like O and B stars, they could very well have blown away all the matter in protoplanetary disks, if you want to call it that. Is that pretty much what you said?
Yeah, kind of. I was just suggesting that the as you said, the high stellar winds would definitely affect planetary formation, because those high stellar winds are going to have a tremendous outflow of energy, and that outflow of energy, as we see in locations like M16, the Pillars of Creation, we see how only the densest areas can remain untouched, and then that stuff is blown away and scours out the regions. So leaving these pillars behind, because those densities at the end of the pillars are keeping the rest of the pillar from eroding away. So the stuff hits here and doesn't penetrate through to remove the whole stalk. So we always see these stalks pointing toward the hot clusters in these stars, or in these nebulae. If the stellar wind is strong enough, you're just not going to get planetary formation. Not unless you're in a very, very dense dark cloud, and that might actually allow for it. And that's something that would be possible if you had a very high density of stellar dust, interstellar dust. So that's what would be required for that.
Yeah, and you could say the difference would be those really big bright stars blowing the pillars away are young stars, while this is a very, very old star. Basically, the star is dead now. It's died and become a white dwarf.
Yeah.
And old big stars like Betelgeuse, I could well imagine they might have had planets, maybe moons. before it became a red supergiant. I guess something like Betelgeuse would have been a blue supergiant, so maybe not after all.
Hmm. Yeah, Betelgeuse used to be a bright blue O star. That's actually kind of what we've thought for a long, long time.
Yeah.
And like if Lucy looked up in the sky, I've said this so many times. If Lucy looked up in the sky 4.2 million years ago, the upper left star in Orion would have been bright blue. It wouldn't have been red. That's a recent change to Betelgeuse. And so Betelgeuse only is going to exist for a few million years. It's not going to exist longer than that because, of course, Betelgeuse has a problem. Betelgeuse eats up its and goes through its hydrogen very, very quickly. And now all that's left for Betelgeuse is, unfortunately, to actually just expand into a red giant prior to going supernova. In which case, it's going to go supernova. It's going to blow up, and that's going to be the end of it. However, I can't wait because that'll be a really pretty sight for us to see.
There's been some talk recently that Betelgeuse, some are thinking now that I guess it was a double star, and that its secondary is actually inside the envelope of Betelgeuse now.
Yeah, that can happen with these very tenuous red giants. I say super giants, because if you put Betelgeuse where the sun is, it'll go out to the orbit of Jupiter, and that's a sphere, remember, all the way around. So is it possible there's a small stellar component with Betelgeuse that could actually be orbiting within Betelgeuse? Yeah, because that's a very tenuous atmosphere out there. It's not in the middle of a radiative envelope of a star or a major convective envelope of a star. It's in the convection zone, but it's not. It's in the outer reaches, so it might be just skirting around out there, and that's pretty fascinating. Really is. So I guess 36 we got of this. That's really pretty.
You can see the outer lobes are showing up.
Yeah, right
at
here.
At least the first outer. Well, I was taking that inner one. If you see that eye shape again, yeah,
right
the lobe there at lower left, and then the one at upper right has a little red fuzz in it.
Yeah, that's the one I mentioned earlier, having the red in it.
Yeah.
And then if we zoom out, okay, you'll notice that it's got a farther lobe out here.
Yes.
And let's actually just blast it in here, just to show it a little clearer. Now it's very clear. You see this, you see that.
Yeah.
And we'll save that, and we'll save it exactly as seen. Very nice. Okay. Well, I'm going to show us one more. So we're going to come off the planetary nebula, the end of the star. That's the white dwarf, as I said. And Daryl said, and this is the envelope of the star, what used to be in the star, in the atmosphere of the star, now pushed away by what were originally, back tens of thousands of years ago or more, thermal pulses of the red giant, expanding and contracting, and that corresponded to the different nuclear fuels that it was fusing within its core and just outside the core. And as it got new ones, it would expand. As those materials started to wane, it would shrink again. So the star would do these pulses, and these thermal pulses were the thing that actually drove the star to push out its outer envelope like this. And as it does that, it literally is pushing the outer envelope away from the core, and the core of this star became the white dwarf. All right, and it collapsed to a certain point because it had a certain amount of mass, but similar to the sun, plus or minus a small amount. And as it tried to shrink more and more and more, as it tried to contract, gravity could not win out over something called electron degeneracy pressure, which is the pressure of electrons pushing outward in all directions, this way, that way, every which way. and it prevents the star from collapsing further. There's no more fusion going on. It's just a cooling stellar remnant. Okay, and this is what we see with this. That's the nature of planetary nebulae like this. I can't wait to see the helix, by the way.
When white dwarfs cool off, they become black dwarfs.
Yep.
I don't know if
And not
the
one
universe...
white dwarf has cooled yet since the beginning of the universe.
Right.
And the smallest stars in the universe are the red stars, smallest mass, smallest luminosity or intrinsic brightness, which is the total energy they give off. And they could be 1/100th the size of the sun. And the first one of those that was ever created is still in existence because those stars live trillions of years. They actually have the ability to fuse hydrogen very slowly, but they're also what are called fully convective. The hydrogen, the fuel, the entire envelope of the star goes down into the core and out again. Okay, so hydrogen's constantly being replenished in the core of these really low mass stars, and they tend to be red. They're the red dwarfs are called.
Right.
So pretty interesting stuff. Okay, we're gonna take one more shot here. Like we're gonna go to 45 shots, and then we're gonna come off of this because I do want to show you an example of what I'm talking about with the stellar wind issue. And so we're going to save this here. Save exactly as seen. Okay. Now let's go back to our low light mode here. And our low light mode will serve to allow us to see the next thing up for bids and the price is right. Alright. And that will be an object in our Milky Way right now, which is going to be down here. That's the Dumbbell Nebula there. We'll go through Aquila, through the Milky Way. You see that here. And we're going to come down here and move here. And I want to show you those pillars we've been talking about. I think, we should be moving away from any potential clouds, if there's any coming. I think we're going to be out of the way of them.
Mark,
Okay,
excuse me again a moment, please.
Sure, go ahead. Okay, we're going here, by the way. So let's do this. Okay. And let's do this. Alright, guys. Hey. Oops. Yeah, we're getting a rotator system that will allow us to rotate the angles here of everything. Okay, so let's do this. Alright, that should be good. Okay, this is a bright, hot, young cluster. And that cluster is actually something that is very much, the stellar winds we're talking about that will actually create these pillars. And you can actually start to see them here very faintly. And I've got this in the other telescope as well. And we're going to actually take an image of this and capture all of this right here. This is a close-up view, all right, and in this telescope, the other side, we're going to be looking at a different view of the whole region. And here's the cluster, and here are the pillars. Now, in here, in this image, here's the cluster, and here are the pillars. You see the difference in size. This is a massively large object right here. Okay, now let's do this. Let's go and grab our guide star. So we're going to do this right now. There we go. Let's come out. Let's actually grab multiple stars. There we go. That's a perfect guide star. Alright, let's sharpen it up a little bit. There we go. Excellent. Alright, so our guide star is going to be just fine. Now what we'll do is come over here. We're going to do a 25-second photo of this guy. And we're going to see a tremendous amount of these pillars. Now we're going to go into deep sky mode over here. So we're on our way with that one. And then over in this telescope, we're already guiding. And let me just tweak it. There we are. And what we're going to do now is we're going to come over here and start a 25-second photo here as well. Alright, so there we go. And you're going to start to see, when we're done, you can see the entire region. Alright, so we're going to start this one as well. Okay. We got the live stack coming in. We're going to clear this last image of the galaxy because that's already up there. And let's check out the other telescope. Oh, look at that. And now you can see the pillars of creation. Look at that, guys. Alright, so here is our bright cluster, and here are those pillars. Okay? Let's make sure we got our... Yeah, we had some wind knock us out, but it'll realign. It'll catch it again. I specified a search area around a star image. Nice image. Nice, beautiful image. Okay. Alright, so here is that. Now let's...
This camera does the eagle much better.
Yeah. And what we're going to do is... Let's actually do that. And let's move our black level up. Climb that. Look at this. And over here is the fairy. And here is the pillars of creation. Pay attention to this little guy over here too. This little guy is interesting. And what I'll do is, just because this will be a good item, I'm going to move this down. Okay. And allow us to actually see the entire object up close. Look at that. Really nice. Okay. In the other telescope, we've got it as well. And what we're going to do is color correct that. Alright. And you'll notice the difference in size and color, but that's okay. Let me just move this over. Alright, here we go. Okay, there we go. Alright. Okay, now, this is the entire nebula seen at a glance, okay? And so, it looks very different from this guy, right? Because this is a close-up, right, of a central section of this, right? And that central section's right here. So, in this particular view, what you should notice, and can notice, is that our other telescope's field of view is like this. And it's a square field. Okay? Alright? So that's what we see zoomed in here. Okay? Is that whole section. The colors are a little different. The color rendering on this one, a little different than the color rendering on this one. And I want to check something to see if that's something that is something I can change. That's always been really pretty.
I see a straight line to the right of the
this right
eagle in this view. Yes, that right there. Satellite, I assume.
Yeah, that's probably a satellite going right in front of the nebula. Those satellites, you try shouting them out, and still they keep coming back. Wow. Okay, let's do this. All right. Oh, well, there we go. Okay. I changed the rendering of the colors to match what's over here. So this color rendering should be different now. It was incorrect earlier. And let's see what it does to the colors. See if I have to start over. Yeah, see how it's getting redder? Okay. All right. Yeah, look at that. Wow.
Nomad, the red light means it's hydrogen, ionized hydrogen.
Yeah, that's the red light. Yep. Okay. Let's do this. All right, I'm going to do this. I'm going to clear this and let it redo a shot because we need to get the colors correct. So we'll come back here and look at our beautiful imagery here. This guy, you can see if we bring up the stack here for a minute, and let me just shrink this down for a moment. All right, bring up our stacking. And let's pull that right to that limit. And let's move this over. These lines are looking at the data, which is here under this curve. And so we try to take a profile, basically an additive snapshot of everything we see here. All right, and that's what this is about. All right.
I'm going to ask a question of the chat crowd.
Okay.
It's popular to call this the Pillars of Creation now, after the Hubble image. Historically, it is called the Eagle Nebula, Messier 16. Do you see the eagle, people?
I should back out a little more.
Well, that's good right there. Anywhere there. Do you see the eagle? The wing is on the left. The head is in that dark space going up to the upper right, the big one. And its neck and body. And then the thing on the right is its foot.
This here?
Huh? No. Go right to the central pillar of the Pillars of Creation. Not that one, the next one.
The
one to
central
the right,
pillar,
right
okay.
there. That
I
is
thought you
the
meant
head.
the central.
That one is the head, neck, and body of the eagle. The
Okay, and
curved
this is
one
the
to the lower
talons?
left, and that's his talons. And then the
Okay.
curved one to the lower left is its wing.
This here?
That, yes,
Okay.
that is the eagle.
No, it's subjective, I guess, because when you look at the other image, okay, this whole thing looks like an eagle with its outstretched wings and its head up here. So it's as a whole can also be the eagle as well. Interesting. But here you can see as we zoom in, okay, to show you the difference in the resolution. Okay, here we are zoomed in, all right? And there's the pillars of creation in our wide field system. And here's the pillars of creation in our narrow field system. Look at the difference in the quality, right? This image is not meant to be zoomed in a lot. What it's meant to do is be zoomed out a lot to show you the full extent of all this vast nebulous detail. See? That's what it's for. There's a beautiful cluster right here too. Let's see if it recognizes. It doesn't know that. This is the Eagle Nebula cluster. That's the Eagle Nebula. This is also known as the Star Queen Nebula, which I never knew of it that way ever. You know? I never knew it that way ever. Okay. Save with annotations so I can get out of it.
Mind you, in the days of visual astronomy, through the eyepiece, all they saw was the central brightest area of the nebula.
Mm-hmm.
I doubt that dark, the fainter stuff to the outside wasn't much visible at all.
Oh, I agree with you. I agree with you. Now, remember that little spot I was telling you guys to keep an eye on? Look at it. Now you can see what's going on here, and this right here gives you a great idea of how nebulae work. Okay, hot young star cluster, lots of stellar wind, pushing down and blowing out spherically in all directions around the center of this nebula. What the hot young stars do is they carve out a cavity, an empty space in here, where they push all the gas and dust away from themselves. So once they form, it's like they cannibalize the rest of the cluster or the gas cloud, so no more stars can form. It's kind of interesting. Now, they certainly don't have that real sense, but the stellar wind beats down on these areas over here and over here and over here. Okay, and it's radial. See, radial direction. Okay, and all in the other directions as well. And let's just take this one. So the starlight comes down here. This is a fairly dense top, or a dense area in the nebula. And so the density of this thick area right up here is protecting what's behind it from being eroded away. Okay, same thing here. Dense at the top. You're protecting what's being behind it, what's trying to be eroded away back there, but not in between. In between, it could erode. Okay, and it's gotten to about here, and maybe there's more to come. Because again, this entire nebula is maybe only a few tens to hundreds of millions of years old. That's it. All right, and then we have this very dense area here, again protecting what's behind it to some extent. Then you see this one. Notice the shape. It's got a little teardrop shape where the point of the teardrop, the round part of the front of the teardrop, is pointing right back at this cluster. So this is a very dense area, and it's trying to be eroded, but it can't be because it's too dense. And maybe inside that density, the density is high enough that we're finding, or could find, that maybe there is the ability of stars forming in there that may not be visible without using the James Webb to look. And maybe there might be planets around any star that's in there. And this means that this type of situation is where you could actually get planets with a star inside, as long as it's dense enough to be protected by from the radiation of these hot stars outside. Okay. Go
ahead.
What?
Sorry.
I was going to
Go
say
ahead.
this. Okay. This little object right here might be designated a proplid, a protoplanetary system, and we see those in Orion. We see those elsewhere, other nebulae. But go ahead, Daryl. You can say it now.
If you look below the little dark blob, there is a lighter blob straight down below it, right there. And it's less dark. There's still a little shadow on the bottom of it. Then maybe it's evaporated farther than the darker one has, and it looks like there is a star coming out of it. Maybe it's farther evolved or degraded worse than the darker one has, and it's mostly blown away, and maybe that's revealing that star now.
It's possible. It's possible, or it's a background star or a foreground star, but all those things are possible. I'd love to find out. I'd love to know. You know, but that's interesting. That's interesting stuff to me because when I look at this nebula, this guy right here, this looks like for all the world like what I would call a Bok globule. Barche Bok, B-O-K, was an astronomer who discovered that these dark objects inside nebulae were seemingly the birthplaces of new star systems. And so Bok globules are always very important. They're very important to me because, as I said, life begins in the dark. And so inside these dark nebulae, within these clouds of dust and gas, there might be these protected areas like this, literally little islands of protected space that don't feel the full wrath of the ultraviolet radiation from these stars. And if that's the case, there might be the ability for stars forming in there to actually have planets as well. And that's sort of like a age-old possibility, right? But don't get me wrong, this entire region is very hot. So inside this dark nebula, this is dark nebula here, by the way. This is not an area that's, this is not an area that's devoid of stars. It's actually dark nebula overlaying. It's in front of the nebula behind it. Okay, so like I'm showing you with my hands. Okay, so that's in front. This is in front. This is in front, etc., etc.
There are two more
Now
dark
you
globules. Go
Yeah.
ahead.
Well, there's one here.
One there and another to its lower left.
Yeah, right here. Another one of those dim areas that you talked about, like right here. I'd love to see what the James Webb would see. The James Webb looked at this whole region, and this looks like we're seeing mostly nebula with some stars. In fact, that's not true. This entire region is filled with thousands of stars. You just can't see them because they're hidden, and the fact that their light is in the infrared right now because they're young stars. And behind this dark dusting cloud, the infrared can still get out, and James Webb sees that. So if you look up Pillars of Creation, Pillars, Pillars of Creation, James Webb Space Telescope, you'll see an image of just this one region right here, right here, and it will show you all the many stars that are inside this region that you just don't get to see. It's absolutely incredible. So do that, Pillars of Creation, James Webb, and you'll see, because the James Webb only sees in the infrared. It doesn't see anything in the visual range like we're seeing right now. But still, it can actually build some really, really substantial images. Okay, so that's there. And then over in our other telescope, this is the images developing over here. Okay, so I'm going to save this. We've got 25 stacked here now. So I'm going to save it there and exactly as seen. All right, so there's our beautiful Eagle Nebula. That's the whole region right there. This is all dark nebula, by the way. Keep in mind, this is in the Milky Way, right? And it's a little bit, northwest or northeast of the center of the Milky Way. So what we're looking at here is all dark nebula in here. Really cool. And there's a hint of it over here. You can see this clearly is dark nebula now. Okay, we're over here. That same region, you can't really tell the difference, right? But this, you can clearly see there's dark nebula in here with tendrils sticking over the bright nebula all throughout here. That's an interesting little region right there.
If you look at
really
the
neat.
Benson image, shows it well. I think you can see some three dimensionality in that in the pillars there toward the
Yeah.
center. The one to the upper left isn't very dark, and it's pretty lightly lit along the top. Then the one in the middle is much darker, and the talon there is even darker. It's like they're staggered. The darker parts are closer to us than the top left pillar, which looks more
Mm-hmm.
like it's under the cluster, and thus
Mm-hmm.
the side facing us is being lit also.
Yes, which is why that's a very good point about the top of the pillar here. Looks like it's being lit from these stars, and it would almost be like it's kind of away, angled away from us, deeper into the page, so to speak. And
Yeah,
this one is closer to us, so we might be looking at it like at an angle like this, which is kind of interesting, and that's possible, very possible.
kind of like looking
Let's
at
see
the
how many
horse
we
in the room.
stacked. Yeah. Okay, here's 46 here, and I'm going to set up our target name here after I identify this. There we go. So M16 Eagle Nebula, we'll set the target name. Okay, we'll save with annotations so you have it saved with all these labels. And then we'll come out. Alright. Now we can start to save with impunity. We have 47. We'll save this. Save it exactly as seen. There we go. Alright. Very nice.
That's a nice picture.
It is. It's really pretty. And let's do one thing. Let me just take that back down just a little bit. This will soften it up a little bit more. Not in terms of out of focus, but help get rid of some of the noise. You see that? That's neat. A lot of detail in this. And you can see that dark nebula up here at the top of this nebula, overlaying the lighter nebula behind it. Very interesting. And then this, of course, becoming even more vibrant. That's probably my favorite part of this whole nebula. Pillars of creation are neat.
I think the same thing applies to the little dark blob on the right, and then the brighter one under it.
That's what I just said.
The darker one is closer to us, and the one under it is farther, more directly under the cluster.
It's possible. Or it could just be angled away from us at the same distance, roughly. Who knows? But you're right. I mean, there's a lot of three-dimensionality, like you said. This looks like it could have more hydrogen gas between us and it that's glowing, causing this to be sort of subdued. So this darkness here should be about as subdued as this, maybe darker. But because of the fact that it might be in the nebula more, so it might be further back into this nebula, maybe that's what's happening, like you were saying.
Then if you look at the very bottom of it, toward the bottom of the screen, there's a bright red line running there along the right-hand edge, yes. That's sort of like the wall we see in Orion near the first head.
Yeah.
Looks like an edge.
And like the North American nebula's wall, the Cygnus wall. Yep.
Nice picture.
Yeah. All right, well, we'll save this one more time with 53 images. We'll save it. Save exactly as seen, and we're in the M16. All right, let's redock and bring our image down the size here so we can capture it all. That's really pretty. And then over in the other telescope, we have this image. 38 captured. We'll save it. We'll save exactly as seen. So there's a nice contrast to go from this to this and see the differences, you know. But I like the idea of zooming in on this to make this as big as it, see it, make it as big as it is in this one. And you can see the difference in the quality. I mean, we can actually, that's still not bad, but I gotta say that if we drop this down a little bit, okay, like that, it'll look kind of like this one. This is the one with much more detail.
Well, that's what focal length at a higher f ratio does that for you.
That's right. That's right. Interestingly, I noticed something else too when it zoomed out. That is, by here we have another blob here and another one here that actually looks like it's a more contracted globule. You know, a gravitationally collapsed globule. That's pretty cool. Neat stuff, man. Yeah, and then this one here, again, this image is not meant to be this large. This image is meant to be zoomed out to show full extents. Alright, and we can actually increase that a little by moving here. Okay, that's alright, that's about there. Alright, so we'll save it there. Wow, this is cool.
I'm turning into a pumpkin, Mark.
Okay, are you don't fall on the ground though, you'll become squash. Yep.
I just flew in from Chicago. Boy, my arms are tired.
I'm trying to do the crickets. Donald Kunzer says, does anybody else see a Klingon warship here? Yeah, no, it looks sort of like a Klingon warship, doesn't it? That is cool, guys. Well, look, I'm really happy you guys joined me tonight, and Daryl and I are happy you guys came. It's so nice to see you all here. We will be back on next clear night, and the moon is increasing in its phase. The moon just set a little while ago. It's sort of approaching first quarter in a couple days, and we'll check it out and look at the moon a little bit as well. I just want to let you know that this is our last object for tonight. It is 2:10 a.m. here on the East Coast, and I want to share with you that I'm really happy you joined us tonight. So please come back again. I look forward to having you come back. And Daryl, thank you so much for joining us again.
Sure.
Yeah, and Fantasy's with us again. Hey, Fantasy. Hein Sherry's with us. Sandy Boy. A lot of people that we know and some that we don't. Very nice to see you guys. Freeze Pops is with us too. Thanks, man. All right, so guys, Kathy Messick, hi. Curtis Horn, have a good night. All right, folks, you guys have a good evening, and we will talk to you on the flip side of all of this. So we'll talk to you later, and have a good night. See you, everybody. Bye-bye.
Good night, everybody.
Good night.
Stars so bright in the sky, on Arizona nights they fly. Nebulae in colors rare, galaxies beyond compare. Sky tour in the night so clear, brings the universe near. Real-time wonders to see, streaming light for you and me. Lift your eyes to the skies, universe in all its light. Sky tours bringing the views. Every night feels brand new. In the dark, night unfolds, stories of the cosmos told. Through the lens, a distant dream, living real like a gleam. Far away, up so high, across the stars beyond the skull. Through the lens, a distant dream, living real like a gleam. Lift your eye up so high, across the stars beyond the sky. Sky tour shows us the way, every night a new display. Lift your eyes to the skies, universe in all its light. Sky tours bringing the views, every night feels brand new. Lift your eyes to the skies, universe in all its light. Sky tours bringing the views, every